Let's talk about section 1.2 objectives. Number 1, solve linear equations in one variable. Number 2, solve linear equations containing fractions. Number 3, solve rational equations with variables in the denominator. Number 4, recognize identities, conditional equations, and inconsistent equations. That is something that's new. Identities are not new. Conditional and consistent are new. You know what they are, you just don't know what they're called. Okay? And then number 5, solve applied problems using mathematical models. This is going to be on there a lot on the objectives. Do you have any idea what it means? Word problems. Yeah, that's exactly right. Word problems. So probably we're going to do examples on the first 4. I'm not going to do an example of a word problem for you because it's like the ones that we just did up here. Does that make sense? Okay. So let's see how much you remember from Algebra 1. 2x plus 5 equals 9. What do I do first? Are you allowed to divide everything by 2 first? Yes. Yes, you are. It typically makes things more difficult because you have to remember to divide everything by 2. That's why we typically do the step of adding or subtracting first, for the record. Okay? So if I subtract both sides by 5, I get 2x equals 4. And to solve for x, I divide both sides by 2, which gives me x equals 2. You got that okay? Is it correct? You could check. 2 times 2 plus 5. Does 9 equal 9? Then I know that's correct without a shadow of a doubt. Okay? So what about this problem? 2x plus 5 over 3 equals 9 over 6. So solving linear equations that contain fractions. Do we want to deal with fractions? No, not if we have to, right? Or unless we have to. So what we want to do is get rid of the fractions. So we find a common denominator, which in this case would be 6, and multiply both sides of the equation by 6. What happens to these two 6's right here? They simplify to what? 1. What happens to it over here? What does that simplify to? 2, right? 6 divided by 3 is 2. So on the left-hand side of the equation, we have 2 times everything right here. Well, what is 2 times everything right here? 4x plus 10 equals 9. And that's super easy to solve, isn't it? Because we do that by subtracting 10 from both sides. 4x equals negative 1. And then we divide both sides by 4. So x equals negative 1/4. Is it right? Negative 1/4 times 2? Negative 1/2. Negative 1/2 plus 5. Be confident. 4.5. 4.5 over 3 equals 9 over 6. So we could put that in our calculator and just hit enter and see if it equaled. But if I multiplied this whole fraction by 1, which is 2 over 2, wouldn't that give me 9 over 6? So isn't it correct? So I know without a shadow of a doubt that's the correct answer. Okay? Our next objective is solving rational equations with variables in the denominator. Okay? Now this is something we did toward the end of the year. Okay, so you've done it more recently, but it was also the first time you had done it. That makes this the second time you have done it, so give yourself a little grace here. Okay? Just like before, we don't want to have to deal with fractions unless we just have to. And in this case, we don't have to, because we can find a common denominator and use that common denominator to get rid of the denominators, right? What would be the common denominator here? So 2x. So if I multiply every term by 2x, what happens on the left-hand side? The x is simplified to 1, and I just am left with 8, right? 2 times 4. So what happens in this first term right here? The 2 simplifies to 1, the x is simplified to 1, and I'm just left with 5. And what happens right here? So plus 6x, right? 3 times 2x is 6x. And once again, now this is a problem we know how to solve relatively simply. Divide both sides, subtract 5 from both sides. 3 equals 6x. And then to solve for x, we just divide by 6. So x equals 1/2. Is that the right answer? We can check, and we should, right? Okay. So 4 divided by 1/2. 8. I'm going to write something down this time just because I don't always trust my brain. Is that fair? 2 times 1/2. 1. 5 over 1. 5. It's okay. 5 plus 3. Does 8 equal 8? So then I know without a shadow of a doubt that that's correct. Okay. Now, if we're solving an equation, sometimes the computer will ask you for the set of all the answers. And if it asks for the set of all the answers, all it's asking you to use is set notation and then write the answer. Okay? But again, that's not something you've seen before, so I wanted to make sure that you saw it before you got to your homework. Yes? Okay. Any questions on that one? So what about this one? So 4 over x plus 5 plus 2 over x minus 5 equals 32 over x squared minus 25. Sorry, that should be a 25. I forgot my 2. So what would be my common denominator? Well, I can factor this. I should probably do that first, right? That's a difference of squares. So x plus 5, x minus 5. Hopefully that helps me see what my common denominator is, right? Yeah, you're right. X plus 5, x minus 5. So I multiply every term by the common denominator. Okay? Each and every term is multiplied by the common denominator. So what happens in my first term? The x plus 5's simplify to 1. I have 4 times x minus 5. Yes? What happens in my second term? Correct. So I'm left with? Perfect. And what happens on the right-hand side? Yeah, that simplifies with that, doesn't it? So we just have 32. Okay. Once again, I'm down to a linear equation with just one variable, right? So 4x minus 20 plus 2x plus 10 equals 32. And now it's just a matter of combining my like terms. 4x plus 2x is 6x. Negative 20 and positive 10 is negative 10. And that should equal 32. When I add 10 to both sides, I get 6x equals 42. And to solve for x, I divide both sides by 6, giving me x equals 7. Is it correct? 7 plus 5 or 12. Yeah, either one. Probably 12 is better, right? 4 over 12 is the same as what? 1/3. 7 minus 5? 2. 2 over 2? 1. So I've got 1/3 and 1, so that's 1 1/3, right? Over here I have 49 minus 25. 24. 32 over 24 simplifies to 4/3, which is 1 1/3. Yeah? Any questions about that? Okay. So let's talk about the stuff that you know but you don't know the name of yet. Is that okay? Okay. So first of all, we have an identity. It would be fun if we had a secret identity, but it's just a mathematical identity that we're talking about. It could look something like this. Because if I simplified the right-hand side, I would have x plus 3 equals x plus 3. And the fact of the matter is that is true. X plus 3 is equal to the exact same thing of x plus 3. That's an identity. Okay? Then I have something called the conditional statement. Conditional. And a conditional statement looks like this. 2x plus 3 equals 17. Why is this a conditional statement? We don't know what x is, right? We have to know what x is. Like that, the value of x is conditional on making the statement true. I can't just say x is 5. Because if I said x is 5, this is not true, is it? I kind of need to know what x is. To be able to know that this statement is now true, but it's conditional based on the value of x. Does that make sense? And then there's something called an inconsistent statement. Inconsistent. And an inconsistent statement is something that looks like this. X equals x plus 7. In what situation would you ever have an x value that's also the same as if you added 7 to it? Never. And if this was like an equation that you were actually trying to solve, that's just a not true statement, is it? 0 does not equal 7. That's what makes it inconsistent. Okay? So, looking back on our objectives, how comfortable do you feel solving linear equations in one variable? How comfortable do you feel solving linear equations with fractions? Less comfortable, but still okay, right? What about rational equations? So fractional equations with variables in the denominator. And then identities, conditional equations, and inconsistent equations. And do you think you can do word problems that contain all of these things up here? Good. Peace.